is the Geiger counter, and if you remember, when the tarmac, we were barely getting 10 to 12, maybe 15 registrations per minute down the tarmac at an elevation of about 4,200 feet. Well, here we are, 8.5 miles higher, and you can see the amazing number of cosmic rays getting through our atmosphere at this point. And the research indicates that for every mile of elevation gain, the amount of cosmic rays we become exposed to doubles. Well, here at 8.2 miles high, if we were getting 15 cosmic rays per minute at ground, up here we're probably getting close to 1,000, more than I can count just by looking at the flashing light. These cosmic rays don't come from the sun, they come from deep space, they come from active galactic nuclei, and they come at very high speeds. And interesting statistics that people who spend their lives like airliners, pilots, astronauts, the incidence of cancer generated by these cosmic rays is statistically higher than those of us who spend our life down protected by the Earth's atmosphere, which does a very good job of protecting us from most of these atmospheric penetrators, and they are very real.
So it's kind of weird holding that Geiger counter going, wow, this is really cool. Wow. This is not that cool after all.
They're all hitting the counter.
We talked to the pilots and said, you know, this is really hot up here. And he goes, we had a sensor in the upper floor of the 747, but it made us take it down because they thought that an experiment of this nature would indicate that they know it's dangerous, and all of a sudden there'd have to be laws and forbidding and stuff because they know it's happening. So,
and they were fearing lawsuits from people who get cancer and then sue them because the data is there. So they stripped off the receptor off the airplane. So here we are, Mutt and Jeff here. We're up here with our little Geiger counter generating all this data. The people coming over really interested because NASA is not allowed them to get that data. And so here's the.
They didn't want to serve a journal warning on the side.
Right.
So I put my videos in slow speed and counted the hits per minute or whatever. I also gave this to my students, and they are currently working this up and hopefully get the same information I got. But I couldn't wait for them, so I made my own. But Bob Berman had an article on this, and so I contacted him and told him what we did and what my students are going to do. And he wants me to send him the data that my kids get and let them get a little bit of write-up in Astronomy magazine. Anyway, it's a chaotic thing because, you know, it doesn't come at a nice, smooth rate. But I did a least squares regression for a PE to the RT, and the yellow one is basically a smoothed out curve. Now, we went up 15 or 20 times and stayed in an elevation and did more data. This standard deviation noisy stuff would probably get a lot closer to that yellow curve. But based on our data, this yellow curve shows that we double our intake of cosmic rays about every, I think 8,000 feet I came up with.
8,300 feet.
8,300 feet, okay, so it's not every mile. Well, according to Larry's research, it's every mile. According to our one experiment, which is not enough, it's about every 8,300 feet. And of course, that would probably change once you got beyond a certain point or out of the magnetosphere or whatever. But as far as going through our stratosphere, this is the data.
One of our next projects, of course, is to carry this. This is about as high as people fly. You just don't really fly much higher here.
Yeah, people fly right around here.
So this is about high as we can go, but right now we're working on a project to generate this data under a balloon. We want to double our altitude and see if we get that exact same exponential curve going up. If it continues, or if there blips or levels off, or not. So our next goal is to try to get a detector up about 100,000 feet.
What's the nature of these cosmic rays? They're all gamma rays?
There's a cascading event that
Yeah, they
happens.
begin as gamma rays, and then they hit upper atmosphere nitrogen, and then they sort of cascade and shower down into other things. And so we've got a combination of beta and alpha, but these other things are kind of showering down, right? And they're relativistic. The speeds, of course, of these means that they should decay much quicker, but because they're going at relativistic speeds, time passes more slowly for them, so they penetrate deeper into the atmosphere than they should.
I think down here at sea level, they are the daughters of this cascading, and up higher, they're more of the primordial
Okay, so let's just quickly hear, other things that we also got from that console is looking at data such as temperature and pressure versus altitude. And this, look how astonishingly smooth that curve is in that data.
This is temperature, and that hook there and that hook there, that data was collected in geographically totally different places. So on our ascent out of Palmdale, it was pretty much this stuff. This data, we had to wait till we burned fuel, and we were over, Michigan or something, we got that stuff. So had we gone all the way to 43,000 feet, I have a feeling it would have come down, maybe leveled off, but I don't think we would have hooked up. And of course, this is a beautiful PE to the RT curve that would be expected from the pressure rise, the pressure fall as we rise. And this little glitch right there happened at, was that 24,000 feet? To come over here to 24,000 feet, I got that little glitch right there. I don't know if that was an inversion layer or what that we hit, I do not know, but it's kind of funny.
And so part of the other things, let's just we're pretty much out of time here. So let's just dash on. We stopped, one of the things they did is we went, saw the Endeavor at the California Science Museum in LA. Got to walk around and look at the Endeavor. We also went to Griffith Park Observatory, and I thought we also had final stop at Vasquez Rocks, where Jeff got to stand out there in front of the rocks and say his famous lines.
We're dead, Jim. We were in a presidential briefing at the White House, and this is the nugget that they had on that. And this is page 1, and this is page 2.
So there's our cohort. We made it to the White House. So, and that's it. All kinds of lithos to look at. We got stickers, NASA, stickers, companies, can't get them up. So everything. Thanks for all you do.
Thanks, Matt, for getting us started.
Yes.
Everybody, there's cookies and other